Good. So let's look at it together. Okay, Nico needs different number of people in different phases to execute the latest project he has been allocated. In one phase, he needs 3 people from 2 roles, solvers and strategists. The HR will select 3 people at random without replacement from a pool of, so I have S solvers and T strategists and no other roles. So Nico carefully selected the positive integers S and T so that the probability of selecting a 3-person team consisting of 2 solvers, so 2 solvers plus 1 strategist, the probability of this is exactly 3 times the probability of selecting a 3-person team consisting of 2 strategists plus 1 solver. Yeah. So one thing that it tells me, this probability is far higher. It tells me that the number of solvers is more, right? Because, when I'm selecting 2, then the probability of selecting 2 is far higher as compared to probability of selecting 2 strategists. All right. But anyway, I don't have any actual values of S and T, so I cannot really shortlist something. I can't really do anything like that over here. Look at the question. It says the values of S and T that Nico selected must be such that S is a number that is, and 1 more than, 2 more than. So essentially, we pretty much will need to solve the question using what data is given to us. We can't use the options or use any other methods to arrive at the answer over here. All right. So then let's see, how do we calculate the probability of getting 2 solvers and 1 strategist when I have S solvers and T strategists? We say from S solvers, we are selecting 2 solvers, and from T strategists, we are selecting 1 strategist. This is the favorable probability upon the total probability of selecting 3 people from total S plus T people, right? Now that TP, the total probability, is going to be the same on the left-hand side as well as on the right-hand side. Probability over here is also going to be the same, right? The denominator. So we are just going to cancel it. I'm writing it as TP over here. I don't really want to solve it at all. Or, in fact, if I'm actually solving this question, I'm just going to ignore the total probability because that total is the same for both the sides, for both the probabilities. Yeah. All right, 3 times. So now I have to pick 2 strategists, which means I have to do TC2 and 1 solver, so SC1. Yeah, so this is my probability upon TP. This is my probability of selecting 2 strategists and 1 solver. Yeah, so of course this gets cancelled. Now, how do we calculate SC2? I know that is S minus 1 upon 2 into TC1 is T. This is equal to 3 times. TC2 is T minus 1 upon 2 into SC1 is S. Yeah. You should know, of course, the combinations formula and how to use it, right? This selection formula is very useful. All right. So the first thing I want to simplify. That's all I want to do, right? Because I hate dealing with equations and I have an equation over here. I really don't have a choice because I am being asked the relation between S and T and I'm not even given actual values of S and T in the options. So I really can't do anything over here. So I say, of course, this 2 gets cancelled. Then this S gets cancelled with S. Everything is a multiplication, right? This T gets cancelled with T. What am I left with? I have S minus 1 is equal to 3T minus 3. Yeah, I have these, 2 constants. So I say S minus 1 and I bring it over here. So S plus 2 is equal to 3T. This is my relation between S and T. Yeah. Now let me look at the statement. The values of S and T that Nico selected must be such that S is a number that is dash the number that is dash T. So S is a number that is, 1 more than or 2 more than or 2 less than. S is a number that is, I am given this S plus 2 is equal to 3T. If I say, just think about it, I said this is equal to X and this is also equal to X. Then I'm equating the two, right? I'm equating this side, the left-hand side with the right-hand side. So I can say S is a number which is 2 less than a number that is 3 times T. Because your 3 times T is X and S is a number which is 2 less than X. Yeah, S is a number that is 2 less than less than the number, the number is x over here. S is a number which is 2 less than the number that is 3 times or thrice of t. 3 times t. This x is 3 times t. So this is your answer. We'll select S as here 2 less than, and 2, the t is 3 times. Is this okay? Does this make sense? Yeah, one trap over here, one place where you could make an error is, let's say S is a number which is 2 more than, right? People do sometimes select 2 more than over here. Guys, S plus 2 is equal to x. Yeah, S is not 2 more than x. S is a number which is 2 less than x, right? Because when I add 2 to S, then I get x. Make sense? Yeah, so it will be 2 less than. Is this correct? Is this okay?